Now, what is adsorption? As you know, adsorption is a surface phenomena in which there is accumulation of one substance on the surface of another. This phenomena was first discovered by H. Kaiser. One substance gets attached on the surface of another substance. Now, this is an experiment. In this experiment, take a bottle containing ink solution and add small amount of coconut charcoal. So see here, it will appear like this. After some time, that color in the bottle becomes faint and fainter, and after some time, it gets disappear. That is due to fact that ink pigments are taken away or get adsorbed by coconut charcoal. Example of adsorption. Adsorption of acetic acid on the surface of animal charcoal. Now let us discuss what is adsorbent and adsorbate. The substance on the surface of which adsorption takes place is called adsorbent. So here this substance, it is known as adsorbent. Whereas the substance which gets adsorbed on the surface of another substance is called adsorbate. For example, here these molecules which get attached on the surface of another molecule are known as adsorbate. Now let us discuss the terms adsorption, absorption and sorption. As you know, adsorption is a surface phenomenon, whereas absorption is a bulk phenomenon in which one substance is penetrated into another substance so as to form liquid, solution or compound. There is another term known as sorption. It is a process in which both adsorption and absorption takes place simultaneously. For example, when hydrogen is taken up by charcoal, it is first condensed on its surface, which is nothing but adsorption. After some time, the hydrogen diffuses slowly into interior of charcoal, forming a solid. This is absorption. So charcoal has adsorbed as well as absorbed hydrogen gas. Now let us discuss how adsorption is a surface phenomena. This is adsorbent. Molecules which are present interior are attracted from all sides, whereas molecules which are present on the surface of adsorbent are attracted only by the interior molecule. And that's why some unbalanced forces or residual forces remains on the surface. Due to this, what happens? That adsorbent, it attracts another molecule so as to satisfy those forces, and thus adsorption takes place. That's why adsorption is a surface phenomena. Now friends, let us discuss various factors affecting adsorption. First is nature of adsorbate. Gases like SO2, NH3, HCl and CO2, which liquidify more easily, are adsorbed more readily than the gases like H2, N2, O2, etc., which do not liquidify easily. This is because the easily liquefied gases have greater van der Waals force of attraction. Second factor affecting is surface area of adsorbent. It is well known that longer the surface area of adsorbent, the larger will be the extent of adsorption under given condition of temperature and pressure. Third factor affecting is effect of temperature. As you know, adsorption is an exothermic process. That means during adsorption, heat is evolved. And that's why if temperature is given, then adsorption decreases. For example, if the temperature of coconut charcoal is lower from minus 29 degrees centigrade to minus 78 degree of centigrade, the amount of nitrogen gas absorbed increase from 20 to 45 ml under the same pressure. Now let us discuss types of adsorption of gases on soil. There are two main types depending on nature of forces between the gas and the solids: physical adsorption. If the physical forces of attraction hold the gas molecule to the solid, the adsorption is known as physical adsorption. The physical forces are permanent dipole moment, polarization, dispersion effect, van der Waals forces, etc. In case of physical adsorption, the force of attractions are very weak. Therefore, these are characterized by low heat of adsorption. Example of physical adsorption are adsorption of various gases on charcoal and adsorption of nitrogen on mica. Another type of adsorption is chemical adsorption. When the molecule of the adsorbate are held on the surface of adsorbent with the help of strong bond, the adsorption is termed as chemical adsorption. This is also known as chemisorption. Here heat of adsorption, that is heat evol, is 400 kJ per mole. Example of chemical adsorption are adsorption of oxygen on tungsten, then adsorption of hydrogen on nickel, etc. An adsorption isotherm is a relationship between amount of substance absorbed by the adsorbate and the equilibrium pressure or concentration at constant temperature. Now let us discuss various adsorption isotherms. First adsorption isotherm is Freundlich adsorption isotherm. This adsorption isotherm was proposed by Freundlich in 1909, and he just gave an equation: x by m is equal to k into p raised to power 1 by n, where x is amount of adsorbate, m is amount of adsorbent, and p is a pressure. K and n, these are the two constants which depends on nature of adsorbate and adsorbent. Now if instead of gas solution is used, then this equation becomes x by n is equal to k into c raised to power 1 by n, where c is nothing but concentration of solute in gram mole per liter. Now how to verify this Freundlich adsorption isotherm? By taking logarithm to the equation x by m is equal to k into p raised to power 1 by n, we get log x by n is equal to log k plus 1 by n into log p. Here we have to use properties of log. Now this equation is similar to a straight line equation: y is equal to mx plus c. That means on y-axis, if we take log x by n, and on x-axis log p, so we get a straight line having intercept log k and slope 1 by n. But it is observed that at higher pressure, log x by m remains constant. That means Freundlich adsorption isotherm is fail at high pressure. These are the limitations of Freundlich adsorption isotherm. It is valid over a certain range of pressure only. The constant K and N vary with temperature. As you know, adsorption isotherm means nothing but relationship between amount of adsorption and pressure at constant temperature. Now if K and N, these are depend on temperature, that means that equation depend on temperature. That's why this is limitation of this Freundlich adsorption isotherm. And last one is that Freundlich adsorption equation is purely empirical formula without theoretical foundation. That means there is no any theory or postulate. It is just